Hi, my name is Shubham Salunke. Today date is 25 September 2024 and today topic is JVM Architecture in Java. Today I am going to talk about JVM Architecture. In Java, JVM stand for Java Virtual Machine. It is a core part of the Java programming language and plays a critical role in making Java platform independent. First is the what is the JVM? The JVM is a virtual machine that allows a computer to run Java program. When you write a program in Java, you don't run directly and your computer hardware. Instead, the program runs on the virtual machine. The JVM which translate your Java code into a instruction that the compiler understand. Then second is why is the JVM important? The JVM is important because it will make the Java platform independent. This means the Java code can run any operating system, whether it's Windows, Mac or Linux, without a modification. You can with your program once and it can run anywhere that has a JVM installed. This is often called write once, run anywhere. Third is how does the JVM work? Let me explain this in simple steps. First is when you write a Java code, it is saved in a file within a .java extension. Next, the code is compiled by the Java compiler. It run into something called bytecode. This bytecode is saved in file with a .class extension. Now the JVM comes into section. The JVM takes the bytecode and translate into machine code in that your computer in that computer can execute. This is the key function of the JVM. Fourth is the JVM architecture. JVM The JVM has several parts that work together to run Java program. Let's break it down into similar components. A class loader. The first is component of the JVM in the class loader. It is responsible for loading JVM classes into memory. There are the .class file that contain the bytecode. It working with the steps. First is loading. It's loading the .class file. Second is linking. It is check the code is properly formatted and proper it is for execute. Third is initialization. Initialization is the static variables and methods. Then second is runtime data areas. Once the classes is loaded, the JVM allocates memory for different parts of the program. These memory areas are known as runtime data areas. The important ones are heap. The heap where all the objects created in programming are stored. Then second is stack. This stack the method call and local variables where every time you call a method, a new frame it is added to a stack. Third is a method area. Store the classes structure such as the name of classes, method and contents. Then PC registration. This keeps track of the current instruction being executed and being executed. Then native method. This is the to store information for native method which has written in other language like C or C++. Execution. Last step is execution engine. Execution engine. Now that everything is loaded and memory is allocated, the execution engine start working. It is responsible for execute the Java bytecode. The execution engine has two parts. First is interpreter. It Interpreter is for it reads execute the bytecode line by line. However, interpreter line by line can be slow. Then JIT, just in time compiler. To improve speed, the JIT compiler come into play. It compiles intersection by bytecode into machine code, which are much fresher to execute. This compiled code is cached, so it is does not to be recompletes each item. This is all our information in JVM, and JVM is a main important part in Java. Okay, thank you.